Hi friends, in this episode we will see about thermostatic trap. What is thermostatic trap? How it works? Thermostatic traps operate on the temperature difference between steam at saturated temperature and condensate subcooled to some degree. When steam enters a thermostatic trap, the heat causes a capsule in the trap to expand, closing off the drain valve. As more cooled condensate fills the trap, its lower temperature causes the capsule to shrink again. This opens the drain valve back up, allowing the condensate to drain away. Thermostatic traps are not only efficient, taking effectively zero steam, they are also repairable inline. So servicing doesn't require a lot of disassembly work. Disassembly work. Thermostatic traps respond to changes in temperature and therefore discriminate very well between steam and cooler non-condensable gases. They can rapidly purge air from a system, especially on a cold startup, and can be installed in various positions. Most frequently, actuation is by means of a bimetallic element or a bellow, a capsule filled with evaporating liquid. This is a working principle of the thermostatic trap. Two types, bimetallic type and bellows type. We'll see the working principle in the next slides. This is a schematic diagram of thermostatic bimetallic type trap. This is the bimetallic strip. This is the wall, outlet line, inlet line, and condensate coming in. Now we can see how a bimetallic trap works. The trap consists of a wall and seat and a stack of bimetallic elements. Bimetallic steam trap utilizes the sensible heat in the condensate in conjunction with line pressure to open and close a valve mechanism. So in condensate, it uses a sensible heat and it uses a bimetallic strip to open and close this valve. On startup, the valve is wide open for high flow rates of air and condensate. The subcooled condensate is discharged in a continuous modulating manner. Here, this condensate is discharged. The valve and seat system is usually arranged so that supply pressure tends to open the valve. The bimetallic elements are in the form of a small disc and are arranged to produce a closing force with increasing temperature. Closing force is an opposition to the opening force created by supply pressure. If the supply pressure will act and the bimetallic disc will oppose go up and close the valve, it will oppose the pressure of the inlet pressure supplied by the condensate. This is the condensate line and this is the condensate outlet. After it is cooled, it will come out. This is the working principle of bimetallic trap. Now we can see the bimetallic thermostatic trap advantage and disadvantage. It is rugged, energy efficient, and it is self-draining. It will give resistance to freeze, so it will not damage in frozen temperature, low temperature. It withstands water hammering because it is rugged. Capable of discharge temperature adjustment. You can adjust relative discharge temperature. Can be mounted in several positions. Primary failure mode open. So when the trap got damaged, it will open and continuously you can see the steam coming out, so you can take it for repair. The disadvantage is that particles can prevent tight valve closing. That particle present in this condensate, it will prevent the valve closing. So continuously some dripping will be there. Condensate discharge temperatures do not follow the saturation curve closely. The condensate discharge will not follow the temperature curve, saturation curve. Difficult to field check when operating in a throttling mode. When you throttle the trap, you cannot check whether it is working or not. Condensate discharge temperature is made lower as back pressure increases. So when the back pressure acted on the condensate header, that will make the discharge temperature much lower. So it will be slow response to changing condensate load. The condensate load varies, then the response of the trap will be less. Bimetallic elements are relatively susceptible to corrosion. So any corrosive material or the water condensate is having any foreign material, it will corrode the bimetallic element frequently, and that will damage the trap, and the functioning of the trap will back will collapse. So the elements will relatively susceptible to corrosion. Now we can see the another type, bellow type thermostatic trap. This is a schematic diagram. This is a bellow element. Steam or not condensate depending on the trap. Steam condensate inlet line. This is heating arrangement. Liquid condition and it is flash out. This is the valve. How bellow type trap works, you can see now. Bellows. This is a balanced pressure bellows trap. It has a liquid filled bellow, a valve, and a seat. The valve and seating. The bellows respond to changes in condensate temperature within the trap body and operates the valve. When cool air condensate enters, the bellows cools and contracts, opening the valve. When hot condensate enters the trap, the bellows heats up and begin to expand, throttling the valves, sealing it before live steam enters the trap. Depending on the condensate load, bellows traps may discharge continuously in modulating fashion or open and close cyclically. So this bellow will act accordingly based on the temperature. When cool air or condensate, bellow will contract and allow the condensate to go out. When steam or hot temperature comes, it will expand and close the valve and the flow will be intermittent. Bellows traps are thermostatic traps that respond to changes in temperature and pressure of the steam supply to open and close the valve. The valve actuator is a capsule or bellows filled with evaporating liquid and having both a fixed and a free moving end. It opens or closes the valve in response to internal pressure changes. The most frequently used actuating element is a corrugated bellows. Single diaphragm capsules are also used but provided a correspondingly shorter stroke. It's a corrugated bellow arrangement and it is filled with liquid, vaporizing liquid. So based on the temperature, the bellow will expand or contract and that will close the valve, so it will block the steam to pass. When the temperature or condensate is coming, it will contract and the condensate will come out and will flash out. And steam is coming, that is the temperature of the bellows will expand and it will close the valve, so steam will not pass out. This is the working principle of bellow type trap. Now we can see the advantages and disadvantages of the thermostatic bellow type trap. It is an excellent air handling capability, energy efficient. It's having self-draining capacity. Various condensate discharge temperature available depending on bellow design based on single or multiple corrugated type. Condensate discharge temperature can use various temperature. Condensate discharge temperature follows the saturation curve. Unlike bimetallic type, it can handle and it can follow saturation curve. Can be mounted in several positions. Can be mounted horizontally or vertical. It is simple in construction because so that it can be used in a vertical position or horizontal position. It is small size and weight also very less. Bellow elements tend to failure prone, especially when subject to water hammering. So when that hammering happens, it will damage the bellow and the trap will fail. It is difficult to field check when operating in a throttling mode. So when the trap is operated in throttling mode, we cannot check whether the trap is functioning or not. It is not suitable for high pressure application. Also for superior temperature application, also its application is limited. Short stroke diagram design susceptible to dirt initiated failures. So single stroke or single diaphragm is used that's susceptible to dirt initiated failures, so it will fail frequently. So hope you might understand the thermostatic trap, two type bimetallic and bellow type operation, working principle, advantages and disadvantages of the trap. Do not forget to subscribe or share with your friends. Don't forget to put likes and comments in the comment box. See you in the next episode with mechanical type trap. Thank you very much.